Projectile. What we want to do with today is by solving some questions and use to explain how you're able to get it better for a future question that you have. For example, you have a question like this. An object R leaves a platform XY with horizontal velocity 7 meters per second and lands at Q. If it takes the same object 0.3 seconds to fall freely from Y to P, calculate the distance PQ. Take G as 10 meters per second. Now, the object is moving like this. This is the point XY, and it is moving like this to PQ. Naturally, it is moved like this, but they say it's moved in another right angle degree, fall freely down. It's 0.3 seconds. And recall, this is a 90 degree and 90 degree. This place must be equal to this place. Now, the horizontal, the vertical velocity, the vertical initial velocity is U sine theta. So we need to find the vertical initial velocity because it falls freely, down freely. So we have our U given is 7 meters per second to multiply sine 90 degree. So in multiplying with sine 90 degree is 1, which is 7 times 1 is equal to 7 meters per second. So that is in the component, initial velocity of Y is 7 meters per second. So, and we have been given time. We have been given time to be 0.3 seconds. So now, and the velocity, that is initial velocity, is distance over time, and we need, from the question given, we have to calculate the distance, which is UT, and we are able to get the U of Y because it moves in vertical axis. So to multiply T, and UY is 7 meters per second to multiply 0.3 seconds, which is 7 meters per second times 0.3 seconds. We cancel, so to give you 2.1 meters. So it is 2.1 meters. It is between the Y and P. And it is equal because they form the same right angle. It is same right angle degree. So therefore, YP, the line YP is equal to line PQ. So therefore, the answer for PQ is 2.1 meters. So that is how we solve. So let's also have another reasonable questions again for the next one. So we have another question is this. A ball is projected horizontally from top of a hill. Now let's try to get an hill. Let's try to get a shape. So this is the hill. It's projected like from this point. Is projected like this. Let's try to note this. Yes, this is how it's projected. This is V, this is theta. And we're given the 20 meters per second. So therefore, if it reaches ground in 4 seconds, at this place it reaches here at 4 seconds, you now say that what is the height of the hill? So this is the height of the hill. So we need to calculate the height here. How do we calculate height? At this point, the initial velocity has no value because it started with, it is here. It has nothing to do, the velocity has nothing to do with the height of the hill because it moved here. So at this point, when it started, initial velocity is equal to 0 meters per second. And from the equation of motion that H is equal to UT plus half gt square, it is what you are going to obey. U is equal to 0 times t plus half gt square. So that is why the height, the formula for the height, you know this one will turn out to 0. So now be half gt square. Now, we will be given the value of t, half times acceleration to the gravity, which is 10. It has been given, to multiply 4 square. So 2 here 1, 2 here 5, which is equal to 5 times 16 to give you 80 meter. So therefore, so the height, what is the height of the hill? It is now 80 meters. So that is how to calculate the value of the. So let's also solve another question. That is question 3. An object is projected with a velocity of 100 meters per second from the ground. Let's try to draw it and see how it looks like. It's projected like this. It moves like this. Now, at an angle of theta to vertical, this is y-axis, this is x-axis. Now, but there's a statement mentioned, it said to the vertical, this is theta. Now, telling you that it does not make, there are some certain statements you need to consider in projectile if we move like this. There's an angle like this, we call it to the horizontal, but this is to the vertical. To the vertical. Now, if it is to the vertical, something will change from here. Remember, we have, this is u, x, u, y. Now, the uy will now be, instead of theta sine theta, theta sine theta, it will now be theta cos theta, and the ux will now be theta sine theta. It will change because the question says to the vertical. Therefore, say if the total time of flight of the projectile is 10, the formula for total flight, the time of flight is equal to 2u sine theta over g. This is the formula for the total flight. It is 2u sine theta over g. But because it is to the vertical, it is not to the horizontal. So the theta, so our uy will now change to 2u cos theta over g. Please, you need to take note of this very well for some certain question. And you are given the initial velocity to be 100. So, and the time of flight is also given to be 10 seconds. We have 10 seconds is equal to 2 times 100 times cos theta over g, which is 10. It gives you 100 is equal to 200 cos theta. Let's try to make cos theta as the subject of the formula. We have 100 over 200. It cancels. So cos theta is equal to 1 over 2. Therefore, as this angle, we have theta is equal to second function of the cos of half, which is equal to 60 degrees. So the angle being used is 60 degrees. So what exactly you need to take note is cos theta and the sin theta to the vertical. So maybe the next example will surely explain another question related to the second practical. So now, another question is this. It said an object is projected with velocity of 100 meters per second at an angle of 60 degrees to the vertical. Calculate time taken to reach the maximum height. Now, let's consider this again. Remember, it made the same statement. This is x-axis. This is y-axis. Now, I've tried to explain before now that we are given u again to be 100 meters per second. Therefore, now, but the statement said that angle to the vertical, again, it occurs again like this, telling you that your ux, your uy is now in different forms. So, and the time taken to reach the maximum height, this is this point, it has a quite different formula. That is small t is equal to u sin theta over g. But remember, because of the vertical statement, because the angle made to the vertical, the sign will surely change to cos, because uy has changed to u cos theta. So therefore, our time to reach the maximum height, time to reach the maximum height will now be u cos theta over g, which is equal to, and our u is 100 times cos 60 degrees over 10. So therefore, we have a small t is equal to, this we cancel this. We have 10 to multiply 0.5, which will give you 5 seconds. So just stay tuned to this channel, subscribe and share this video. Thanks for watching.